So more stuff about gradient descent. So it is slow if you're using the whole sample. So in the typical gradient descent, you're computing for all of the samples. Say, for example, you have a data set where you have millions of rows, of course, it's going to take some time, slow. For stochastic gradient descent, you're descending per sample that you have. So it is fast, but jittery, because you can't see the totality. You're only seeing one specific sample that you have in your data set, and you're already trying to update your weights based on that. Whereas in the whole batch gradient descent, you're using everything. So you get to see all the rows that you have, all of the data points. So of course, because you're using all of the data points, you get to have more informed decisions, or in the context of machine learning, it is really optimizing for all of the data points that you have, which is better. But it is slow. So the third option that you have is mini batch gradient descent. It's the one in between. It's faster than gradient descent, and the path is not as jittery as the stochastic gradient descent because it is per batch. It's like the sweet spot, if you think of it that way. In gradient descent, it's the whole data set. In stochastic gradient descent, it's one sample out of, say, millions of data points that you have. In mini batch gradient descent, you specify the batch size. Could be whatever value you could think of, but typically we use, say, for example, 32, 64, 128 as batch size. So we chunk the data set into sizes of 64, and then we update the weights based on that sample. Of course, you'll just be using libraries to do all these things later on, but you have to implement linear regression first, using gradient descent in your homework. So yeah, if you visualize that, it's going to be like this. So you start with that theta value, and the line is like that, and then you keep up on updating it up until you converge here. Yeah, the difference of running batch and stochastic gradient descent. For batch, of course, it's smoother. Again, because you're using everything. And so it depends on what mini batch, stochastic batch. Mini batch, yeah. For the mini batch, that's the one in between. So can't see it here though. Sorry. We're just comparing the batch and this stochastic one here. So this is the minimum loss value that you have for this particular function. So batch is, of course, more smooth, and stochastic is very jittery. Mini batch versus stochastic.